Hi, I'm Mark from Dynex Hobby. Today I'm going to talk about how to balance a two-blade propeller. For this tutorial, I'm going to illustrate two balance cradles that we use at Dynex Hobby. The first one is the Whisper balancing cradle, and that's suitable for smaller propellers in the order of 10 inches or so. We also have the Titan cradle, which can be used for two-plane balancing, but we also have a special adapter that can be applied to the Titan cradle, and this allows you to balance larger propellers for larger drones, for example. This propeller, for example, is a 28-inch propeller. You can also balance many different types of propellers, multi-blade with our new software. This particular blade is a 30-inch 3-blade propeller, and we can actually use the Titan balance cradle and adapter to do that. So what I'll do is I'll illustrate two different cradles, and then I'll demonstrate how to do balancing with the Whisper. Now, the process is actually exactly the same between the two cradles. The only difference is size, really. So this is the Titan cradle that we have set up with the propeller adapter. So the propeller adapter is purchased separately on our web store, and it's actually attached by 4 bolts just below the plate of the propeller. So there's 2 there, and there are 2 on this side. Beneath the propeller adapter is a brushless motor. In this example, I have a in-runner brushless motor. I find the in-runners run very well. They're very quiet too. You can also adapt a outrunner motor assembly, which is mounted to the top of the base plate of the propeller adapter. In this configuration, so I have the motor mounted below the propeller adapter, with the propeller sitting nearly flush with the adapter. So with the propeller for this size, what I've done is I've attached a reflective tape, and that actually aids with the measurement of the motor RPM and also the phase measurement. So this is the Whisper cradle. It's very similar to the Titan cradle, but on a smaller scale. Essentially, it's 2 plates attached by 4 rubber grommets around the outsides of the cradle. Now, this cradle is designed to run at low speed, so you don't want to ramp up the motor too high, otherwise it may actually dislodge from the mount and actually cause injury. If you are concerned, I recommend placing a zip tie through the rubber grommets, and that'll probably secure each one in place. So the motor is mounted to the top plate, and I have the accelerometer mounted to the top plate by 2 fasteners, which is supplied in the kit. So in this setup, I only need 1 accelerometer to measure the vibration, and I have 1 laser sensor, or you could use an IR sensor. On the side of the motor, I've actually placed a reflective tape strip, only because it was very difficult to get a good signal return on a laser sensor. So I have this set up on the impulse. The impulse will be connected to a PC, and also have a speed controller and motor control unit as well. So this whole setup is actually mounted to my bench by 2 self-tapping screws. So it's fairly secure. You want it to be fairly secure just so it doesn't dislodge and cause any injury. Okay, so here's the setup. So we have the accelerometer mounted to the impulse, and a laser sensor module also connected to the impulse. The impulse is connected to a spare USB port on the laptop. Now, to conduct the balance, we're going to need a trial weight. In this case, I'm just going to use a piece of black PVC tape, and that's very easy to work with too. So essentially the process is we apply the tape as a trial weight to the propeller to determine where the heavier and the light side is, and the software will calculate the correction weight. Now, the correction weight can be weight added to the propeller to balance it, or it could actually be weight removed. Some people tend to sand the blades in order to get the balance. Either way, the software will take that into account once you run through the analysis. So what we'll do is we'll open the software up now in Windows, and we'll run through the procedure to set it up for balancing. Alrighty, so what I'm going to do is click on the Multirotor Balancing method. Click on that, go OK, and the following window appears. So once that appears, we can select Devices and the microphone USB audio, and click Start. So with everything at rest now, we can click 0. So 0 basically removes the noise from the system so that the gauges read 0. So the next thing to do is look at the Setup tab. So with this particular setup, for the test, I'm going to be running the motor about 1500 RPM. The mass of the rotor is about 100 grams. and the balance grade is around about 16 millimeters per second. So I've got 2 blades, and the multirotor diameter, I measure that in millimeters, is about 280 millimeters. I'm going to be running this particular motor around about 5,000 RPM as an example. The mass radius is essentially the radial direction from where you apply the balance weight. So it is the distance from the center of the axle of the motor to where you apply the balance weight. In this case, I'm going to be using around about, I'll measure that, 170 millimeters. So I'll put that into the software. Now this propeller spins in a clockwise direction, which is good. So I'll go to the advanced tab. The speed sensor is the IR sensor or the laser sensor, and I'm going to be, the correction action will be adding weight to the system. So everything else is normal. Signal set up and go back to live, and we are good to go. Okay, so now we're ready to start balancing. So the first thing to do is to click on the calibration tab. So the calibration process is essentially teaching the software on what an imbalance looks like, and we do that by applying a trial weight to one side of the propeller and then running the motor and measuring the vibration. Once we do that, then we actually follow through the process, and it determines what they call a calibration coefficient, which is essentially a mathematical model of the system to identify where the imbalance is. All right, so the first thing to do is to click on step 1, and we're going to run our motor at our test speed, which is about 1500 RPM, and then we're going to click record data. So let's go ahead. So just waiting for the dials to settle down, and click record data. And we're going to ramp down. Now we go to step 2. Okay, step 2 says we're going to apply a trial weight at a certain location, in this case at the 0 degree position. So on my propeller, I've got 2 markings. I've got 0 degrees and 180 degrees. So I'm going to apply the trial weight on the 0 degree position, which is about 170 millimeters from the center of the motor axis. So point 2, and we're going to apply that 170 millimeters. Oops, 170. Okay. So I'm going to apply the trial weight about there. Okay. Once I've done that, I'm going to click to step 3. So step 3 says run the motor propeller again, measure the vibration, and record the data. Okay, so now we ramp down, we go to calibration factors, and then we click calibrate. Once that is done, we'll click done. So if you click the advanced settings, you'll see the calibration factors appear there, so you know everything is nominal and ready to go. So click back on live. What we'll do now is remove the trial weight. And so what we'll do is we'll run the propeller again at the test speed and measure the vibration. Okay, so our solution says that we need to apply roughly 0.2 millimeters on the 0 degree position, or on the lighter blade essentially. So I've gone ahead and actually determined or measured the amount of tape which matches that solution, and I'll apply it to the 0 degree position. So that's my correction tape applied to the 0 degree position. So the next step now is to run the motor at this test speed and measure the vibration to make sure that we're actually okay. Now, one thing to note that the unbalance of the propeller is around about 36 gram millimeters, and that's before the correction weight is added. Now, the quality limit on our setup is about 9 gram millimeters. So you might want to look at our previous videos on YouTube and actually talk about what the imbalance in terms of gram millimeters actually means. So let's run the motor again with the correction weight applied to the 0 degree position, and let's see where it is. Okay, so that's a pretty good balance there. So you can see that the quality plane number 1 turns green. So the residual imbalance there of 6.8 gram millimeters is less than the quality limit of 9. So that means that the vibration is less than our acceptable limit. We could keep running through this process again and again. As you can see there, that the solution is now indicating that we need to apply 0.03 grams on the 180 degree position, and that should bring the vibrations down further. For me, this propeller is well balanced, so I think that'll be acceptable to mount onto a drone or aircraft. So that's a very sort of broad overview on how we conduct balancing on a 2-blade propeller. Now, one thing to note that this process can be repeated for a 3-blade propeller. So if I was to get a 3-blade propeller, I would actually label these at 0 degrees, 120 and 240 position. And so when you run the trial weight, you would actually apply it to the 0 degree position, so where this is indicated here. So you run through the same process again, and the software will determine the correction weight. In this case, the correction weight is actually split between 2 blades. So it'll be split between the first blade and the second blade, and the software will actually tell you where that is. Now, the software can determine balance for any number of blades, from 2 blades up to, say, 20 blades. The software will actually do that for you. So there you have it, guys. That's the process for balancing a 2-blade propeller. As mentioned, that this process can be repeated for any number of blades or any setup. We find that the process really does help carbon fiber propellers. Carbon propellers, although they're very strong and very light, they're not a very isotropic material. They seem to have a very uneven weight distribution. So even ones which come, I guess, pre-balanced out of the factory, it's always a good idea to run a test balance just to make sure that it is well balanced and suits your setup. When you perform a balance, it's always best to perform the balance on the motor that you're going to be running with the propeller, if possible. If that's not possible, then any motor will do, as long as the motor is also balanced. So there you have it. Any questions, please post on the link below, and look forward to hearing from you. Thank you.